we're going to expand on something we've been doing, completing the square, and we're going to combine it with imaginary numbers or complex roots and equations. And so what we're going to have here, everything is going to start in a problem that we have had before. It's going to look very similar. We have solved for negative x plus 3x squared plus 5 equals 0 in example 1. Well, if we're solving this by completing the square, that's how we're going to solve on this one, completing the square. What we want to do is make sure we first have it in descending order. So we put 3x squared minus x plus 5 equals 0. And from here, remember we want, when we're completing the square, the first step is to get this 5 on the other side. Get the one with no x attached to it on the other side. So now we have negative 5 equals 3x squared minus x. And I guess I did skip a step. It's all fine. It's all the same from here. But we cannot have a coefficient in front of x squared. Probably should have done that first. It's all still going to be the same. But so therefore we have to divide everything by 3. When we divide everything by 3, we get x squared minus 1 over 3, I'm going to go ahead and keep these parentheses here, equals negative 5 over 3. So I kind of went backwards in my steps, but it's all the same. I'm going to move this up just so we have a little more room to work here. Now the next step was to solve for a. When we solve for a, remember this is the equation we're trying to get, x plus a squared equals k. We take our coefficient of x, which is negative 1/3, and we divide it by 2. Well, when we divide a fraction by 2, we got to multiply by the reciprocal. So this 2 over 1, when we multiply it, becomes 1 over 2. And when we multiply negative 1 times 1 over 3 times 2, we get a equals negative 1/6. So now we have negative 1/6. The next step from here is to square it. Now when we square negative 1/6, we do negative 1 over 6 times negative 1 over 6 and get 1 over 36. From this point, we haven't solved for k yet, but we plug it in technically to both of these spots because it justifies the equation. So say plus 1 over 36 in both spots. And I'm going to erase here, just keep creating room. And now we got to solve for our fractions here. And once we solve there, we will have solved for k. So negative 5 over 3 plus 1 over 36. Got to get a common denominator, so multiply each top and bottom by 12 over 12 to get common denominator of 36. And 5 times 12, we get negative 60. Add these together. K equals negative 59 over 36. So all this is familiar. We've done all this before. The only difference we're going to have is on the k side, it's going to be a negative. So let's go ahead and plug in what we have. Because we got a and k. X minus 1/6 squared equals negative 59 over 36. So now we've matched our equation that we're trying to get to. And we solve. We got 2 square root, get rid of that, square root. X minus 1/6 equals radical negative 59. Radical 36 equals 6, so we come to that point, and it's plus or minus. Hopefully we've got that memorized by now, but add 1/6 to both sides to get 1/6 plus or minus radical negative 59 over 6. Here's the only thing that this lesson is really teaching, because all this you've done before. The only thing it's teaching is we have a negative inside of a radical here. Well, remember, that's not possible to have. That's an imaginary number. So what we got to do is take that radical -1 out and turn this into x equals 1/6 plus or minus square root of 59i over 6. And that is all this lesson teaches. You simply have to solve by getting rid of that negative. I'll show you one more example. Some of y'all may have it, and that's all you need, and you're welcome to stop watching. But if we want to see one more example, and I'll do this one pretty quickly, to solve for this equation. So we got to get descending order. -3 is already in the proper spot where it's supposed to be when we do completing a square. So 5x squared minus 2x equals -3. We got a coefficient, we have a lead coefficient, so we have to divide everything by 5. And we get x squared minus 2/5 x equals -3 over 5. Now we can solve for a. -2 over 5, take our coefficient of x, divided by 2, so multiplied by 1/2. This is nice, the 2's cross out, and we get a equals -1/5. So -1/5. From here we got to find k, so we square it, and when we square that, it would look like this, and we would get -1 times -1 is +1 over 25. Take our +1 over 25, plug it in. Now that we have this set up, we can add our side over here together to solve for k. -3/5 plus 1 over 25. Got to get our common denominator. Obviously 5 goes into 25. So we can multiply by 5 over 5 and get -15 over 25 plus 1 over 25. So k equals -14 over 25. Plug everything back in to our solution here. X minus 1/5 squared, and this is the easy part, right? -14 over 25. This is the part everyone likes to do. We just square root both sides. X minus 1/5 equals plus or minus. I'm going to go ahead and skip the steps and say radical 14i, since we know the I comes out, over square root of 25, 5. Then from this point, we simply add 1/5 to both sides. So our answer is x equals 1/5 plus or minus square root of 14i over 5. And that's how you solve for these complex roots of radical equations.